Hi, this is David Harper of Bionic Turtle with an illustration of the F distribution. This is a distribution we can use to ask ourselves whether the underlying population variances of two different populations might be the same. So to illustrate that, I pulled the daily price returns for two stocks, Google and Yahoo, for small samples. That is for the month of December 2007. So the most recent day is December 31st, 2007, and Google's daily price return for that day was negative 1.59%. So for Google, I have a series of 20 daily periodic returns for the month of December 2007, and I have a second series, a different series of Yahoo's periodic returns, also for 20 days. So I'll move down now below those columns, and just keep in mind we have a small sample for each. And then in Google's case, I'm going to calculate the sample variance. And recall, the variance is a key measure of dispersion. If I take the square root of it, I get the standard deviation or the volatility. So all I want for in Google's case is the sample variance of these 20 periodic returns. With Excel, I can simply do that with the equals VAR function. It takes the range, in this case the 20 daily periodic returns. It's not VARP, instead it's VAR, because VARP is the variance for a population. This is the variance for a small sample, so it's just VAR. I do the same thing for Yahoo, and I get a smaller variance. And now the reason we might use the F distribution is we might simply ask, well, Google's variance is higher, but I'm drawing from a small sample. Is it possible that their underlying population variances are really the same, and this difference is just due to random sampling error? Is the difference statistically significant, or could it just be due to chance, and really the variances are the similar or same? We can use the F distribution to answer that question. I do need to count the number of observations, so that's just a count function for the range above. 20 observations in both cases, and then I compute the F ratio. The F ratio is illustrated right here. It's pretty straightforward. It's the ratio of one sample variance over another. We have S here instead of sigma, which is more familiar to us because Greek sigma connotes population variance. Roman numeral S connotes sample variance. And we want the larger sample variance in the numerator, so this F ratio should always be greater than 1. You'll notice if they're the same, the F ratio will be equal to 1. So in my case, it's a simple division of Google's variance divided by Yahoo's variance, and I get 1.15. In this case, for these samples, Google's variance is 15% greater than Yahoo's. And now we ask ourselves, given that I've drawn from a sample of 20 observations for each stock, is that different enough such that the population variances are really different? Well, I need to pick a confidence. I'm going to pick 90%. As usual, the significance is going to be 1 minus the confidence. So 90% confidence corresponds to 10% significance. And then I can apply the F distribution, or specifically the inverse of the F probability, and I'll start fresh with that. I use the Excel function equals FINV, which is the inverse of the F probability distribution. It takes three parameters. First, the probability, which is, in this case, the significance. That's my 10%, comma. Then I need to give it the 2 degrees of freedom, as we oftentimes do with the probability distributions. So first it's going to be for the X series. That's the variance in the numerator, which is the greater one. In this case, it's Google. That's my number of observations, but I subtract 1, comma. And the third and final parameter is the degrees of freedom for the second series. Again, the number of observations minus 1. So and then I close parens, and so for this function I've got the inverse of the F probability, significance, degrees of freedom, and I hit enter, and I get 1.82. Let's see if I can interpret that with the help of the chart. I have two plots here, and the red plot is the one we're interested in. The red plot characterizes the F distribution with 19, 19 degrees of freedom. That's 19 degrees of freedom for both the X and the Y. That's the red plot. That characterizes this current situation. And 1.82 is somewhere out about here, and what that tells me is with 19, 19 degrees of freedom, 90% of the area under the curve is to the left of this 1.82. In other words, I would expect just randomly, even if the underlying population variances were the same, to get an F ratio up to 1.82. Notice my F ratio is 1.15 right here. It's over here somewhere, well to the left of my 1.82, meaning that 1.15 is something I can reasonably expect given the small sample of 20 each. I would reasonably expect to get an F ratio 1.15. Therefore, I cannot conclude that these variances are really different. Let me do one other thing here and just erase, for example, say 10 of the daily returns, and then I'll come back down here, and now I've got a different set of numbers. Now notice, and so by the way, I went from 10 observations each. That means I now have 9 degrees of freedom for the X and the Y, and so that's why I have another distribution here. The green line characterizes 9 degrees of freedom for each over here, so it's got a different density. And my critical F value is 2.44. It's actually off here to the right where we can't see it. And again, what it says is, for 9 degrees of freedom, 90% of the area is to the left of 2.44. But my F ratio is 2.82, which is over to the right even further than the 2.44. What does that tell me? That tells me in this case the 2.82 is greater than the 2.44. It's over to the right. It's over into that 10% area. And so with 90% confidence, I can conclude Google's variance is different than Yahoo's. Notice in this case, just because of the days that I deleted, Google's variance is significantly higher. It's almost 3 times higher than Yahoo. It's 2.82 times higher. That is greater than 2.44, so with 90% confidence, I reject the idea that they might be the same variance, and I accept the idea that Google's variance is different than Yahoo's. So that's an illustration of the F distribution. This is David Harper, the Bionic Turtle. Thanks for your time.